Okay, let's start with type 2 questions. That is, we have to prove the divisibility. We have to prove divisibility. What I have to prove in this? For every positive integer n, prove that the statement 7 raised to power n minus 3 raised to power n is divisible by 4. What does it mean? What I have to prove is, if I put any positive integer here, n is equals to 1, n is equals to 2, 3, 4, 5, 6, whatever the resulting number is there, that will always be divisible by 4. Is it clear? That will always be divisible by 4. That I need to prove. Alright, so what do I do? The first step remains same as you know by now. That is, let this as statement. Alright, clear? Now what is the first step? Step 1. Step 1 is let n is equals to 1. That means I need to prove if in the given statement I put n is equals to 1, the number which I obtain is divisible by 4. जो भी number आएगा वो किससे divisible होगा? 4 से. This is what I have to prove. Let's check. So I'll put n is equals to 1. So I'm getting 7 minus 3, that is 4, and which is divisible by 4. That's true. Which is divisible by 4. This 4 is divisible by 4. That's true. Clear? So it means the statement is true for n is equals to 1. Or you can say P1 is true. Alright. Now what is step 2? What do we assume in step 2? Let us suppose that the result is true for n is equals to k. That means, what am I assuming? I am assuming if in place of n I put k. So whatever is the number coming, whatever the number I obtain, that is divisible by 4. That's what I am assuming. Is it clear? That's divisible by 4. That means, what am I saying? This pk, if I put n is equals to k, this is divisible by 4. How do we write divisibility? You have done in your previous classes. If I say 10 is divisible by 2, what does it mean? It's equals to 5. That means if I say 10 is divisible by 2, it means 2 into something. 2 into something. If I say 15 is divisible by 3, so I'll say 15 is equals to 3 into 5. Clear? So that number by which it is divisible into the quotient. Clear? Alright. So it means if I say it is divisible by 4, it means this is equals to 4 into something. Let that something be n. When n is this, you need to keep a note, girls. When I say 4 into something, this is divisible. इसका मतलब ये completely divisible है 4 से. So this is equals to, your divisor is equals to 4 into, which is your divisor, this is dividend, is equals to divisor into quotient. So let the quotient be n. I have no idea what is k. So let it be 4 into n. That's given to me. Now what is the next step? The next step is, what do we do in the next step? Step 3. Let us prove the result for n is equals to k plus 1. Let us prove the result equals to n is equals to k plus 1. Alright. Clear? That means I need to prove that. This is what I have to prove. This I am assuming, this I have to prove. What do I need to prove? That if 7 raised to power k plus 1. Now I need to change this n into k plus 1 now because we are finding p k plus 1. So 7 raised to power k plus 1, 3 raised to power k plus 1 should be equals to 4 into something. This is my target. I have to prove this is equals to 4 into something. The something can be any positive integer. That's okay, irrespective of whatever. So it has to be 4 into something. That's my target. That's what I have to prove. Clear? That we will prove. Now what shall I do? In the type 1 which we did, we always use the second step to find some value. Clear? So I can find out the value of some, say if I find the value of 7 raised to power k from here, it will be 4m plus 3 raised to power k. We can find the value. Is it clear? 7 raised to power k can be written as this. Alright. So now I'll put the value here. Can I write this 7 raised to power k plus 1 as 7 raised to power k into 7 and this 3 raised to power k plus 1 as 3 raised to power k into 3? There's no problem. We can split the parts. Now do I have a value of 7 raised to power k? I have a value of 7 raised to power k. Let's put it there. Bring the 7 in front. Put the value. What is the value? 4m plus 3 raised to power k minus 3 into, I'm just keeping this 3 in front, 3 into 3k. So it is 28m, 7 into 3k minus 3 into 3k. So like terms we always add and subtract. This also has 3 raised to power k, this also has 3 raised to power k. So it will become 7 minus 3, 4 into 3 raised to power k. 4 into 3 raised to power k. So can I take 4 common? Clear? 4 I have taken common. So that's what my target is. I'll put it as 4 into t. So pk plus 1 has come where I just mentioned, where k is equals to, this t is equals to 7m plus 3 raised to power k. That's what my target was. What was my target? To prove this divisible by 4. So what was my target? This should be equals to 4 into something, and that's what we have got. This is pk plus 1 has come is equals to 4 into t. So that means pk plus 1 is divisible by 4. Now the result is true for n is equals to 1. Result is true for n is equals to 1. Result is true for, that means result is true for k plus 1 whenever the result is true for n is equals to k. So that means by PMI 7 raised to power n minus 3 raised to power n is divisible by 4 for all positive integers. It is divisible by 4 for all positive integers. I hope it's clear to everyone. The next example of the type 2 only. I have to prove that 2 into 7 raised to power n plus 3 into 5 raised to power n minus 5 is divisible by 24 for all natural numbers. Alright. So that means if I put the value of n whatever, which is a natural number, it has to be divisible by 24. So what's my target? What is my things? What shall I do the first one? I always assume this equals to Pn. That's a statement. So step 1 girls. What is the step 1? Step 1 is I have to prove the statement is true for n is equals to 1. Okay? So let's put n is equals to 1. 2 into 7 plus 3 into 5 minus 5. What are we getting? 14 plus 15, that is 29, minus 5, that is 24. Definitely 24 is divisible by 24. Divisible by 24. Therefore, P1 is true. P1 is true. Clear? That means if I put n is equals to 1, my given statement is true for n is equals to 1. What is step 2 now? The step 2 is We assume the result is true for n is equals to k. Let us assume the result is true for n is equals to k. That means if I find out pk that is divisible by 24, that means pk, that is 2 into 7 raised to power k plus 3 into 5 raised to power k minus 5 is divisible by 24, means 24 into something where m is a positive integer. Is it clear? Alright. Now what is my next step? My next step is, what do we do? Let us prove the result for n is equals to k plus 1. That means I have to prove that pk plus 1 is divisible by 24. That means pk plus 1 should also be equals to 24 into something. Is it clear? 24 into some positive integer. That's what my target is. So, what will be pk plus 1? 2 into 7 raised to power k plus 1. Then it will be 3 into 5 raised to power k plus 1 and minus 5. I have to prove this equals to 24 into something. That's what it is. That we will do. I told you this second step we always use to find the value which can be substituted in the third step to prove our result. ठीक है? तो यहाँ से किसी एक का value निकालें. Let's find the value of 2 raised to power 7 raised to power 2 into 7 raised to power k. क्या हो जाएगी? 24m minus 3 into 5 raised to power k plus 5. Clear? यहाँ से we'll find out the value of 2 into 7 raised to power k. Let's put it here. First of all, let's split it. 7 raised to power k plus 1 can be written as 7 raised to power k into 7. Similarly, 3 into 5 raised to power k into 5 minus 5. Let's solve it a little. 7 I'll keep it here and I have to put the value of 2 into 7 raised to power k. 2 into 7 raised to power k. What is the value of 2 into 7 raised to power k? That is 24m minus 3 into 5k plus 5, and here I can multiply these two. Can be easily multiplied. 15. Alright, let's solve. 24 into 7, 7 into 3, 21 into 5 raised to power k, 7 into 5, 35, so like terms, which are like terms? This is 21 into 5 raised to power k, that is 15 into 5 raised to power k. So subtract, it will be 6 into 5 raised to power k, and 35 minus 5, 30. Alright. Now what is my target? My target is I have to prove this is equals to 24 into something. That's my target. But from here I can take 24 common. But from these two terms 24 is not coming to be common. So that's a problem. So we need to think. Can I take minus 6 common from both? So what I left with? Clear? Now just keep in mind, let's check this. These are all natural numbers now. Let's put k is equals to 1. Let's see kya aa raha hai. If I put k is equals to 1, I am getting 5 minus 5, 0. If I put k is equals to 2, what I am getting? 5 square minus 5, that means 25 minus 5, 20. If I put k is equals to 3, I am getting 5 raised to power 3 minus 5, 125 minus 120. K is equals to 4, I'll get 5 raised to power 4 minus 5. Is it clear? So what type of terms I'm getting? What am I getting? Now what am I getting? If I put k is equals to 1, 0, 20, 120, 220. These all are divisible by multiples of 4. 0 is divisible by 4. 20 is divisible by 4. 120 is divisible by 4. 220 is divisible by 4. Why am I doing it? I have 6. I need 4 more. Because 6 into 4, 24. Then I can take easily 24 common. That means what I have observed from here, this number is divisible by 4. So I can write it as 4 into something. This number is divisible by 4. Please note this step. And put k is equals to 1. 0 is divisible by 4. 20 is divisible by 4. 120 is divisible by 4. 220 is divisible by 4. So that means this is divisible by 4. So I can write it as 4 into something. Now what do I get? Can I take 24 common now? And I can name it as 24 into t, where t is this. So that's it. What did I get? pk plus 1 is 24 into something. That means pk plus 1 is divisible by 24 whenever pk is divisible by 24. Whenever pk is divisible by 24, that's a condition. The result is also true for n is equals to 1. The result is true for n is equals to 1. The result is true for n is equals to k plus 1 whenever the result is true for n is equals to k. Therefore, by PMI, this Pn is divisible by 24 for all n natural numbers. Alright? Is it clear to everyone?